Hey SPH3U, just a quick bonus video of solving a couple of questions that I mentioned in the last video. The first one is number one, this roller coaster problem. Roller coaster efficiency, which you can see in the note here, this roller coaster efficiency thing. And number two is the horsepower of a gun, question mark. So I'll talk about how we could actually figure out the horsepower of a gun. So let's just jump right into it with the roller coaster efficiency problem that's linked here. Now this is really similar to that efficiency lab that we did with the balls and the ramps. But essentially you have a roller coaster, it goes up a hill, right, and then ends up going a certain speed. So you have a 94-meter hill and a 150 km/h speed coming up. These are real figures, by the way. That's the real figures of this actual roller coaster. Let's review our efficiency thing, right? Efficiency is energy out, the useful energy out over the energy in times 100. We have to think about which of these energies is the energy out and which of these energies is the energy in. Well, up here we have EG, we start with EG, and down here we have EK, right? Assuming we set this to 0 height, that means there's no gravitational energy, which means that EG is the energy that we're putting in, right? We're starting with the gravitational energy, and EK is the energy that we're getting out. Down here, I've got the formula sheet open, and those are the formulas for EG and EK. So because we actually have E out and E in, and there's the formulas there, we can just substitute EK for energy out. So 1/2 mv squared for E out. I'm going to put the 1/2 there instead of putting it over 2, because that way it stays in one line. And then E in is m times g times h, because that's the gravitational potential energy, right? That's the equation for gravitational potential, times 100. So that's percent efficiency. I'm going to erase this here just so that we have a bit more room to work. Then magic happens. Notice that I didn't give you the mass of the roller coaster because you don't need it. Because there's mass on top and mass on the bottom, those reduce to 1. So you don't actually need to know the mass of the roller coaster. And indeed, when the roller coaster is actually doing its thing, every time it goes, it's got a different mass because there's different people on it and different amounts of people on it. But it's a similar top speed every time. Mass drops out. We end up with 1/2 v squared over gh times 100. And then from here, nothing else can cancel out, so we just put in our numbers. One thing we got to watch out for, though, remember that everything has to be in meters, seconds, and kilograms in order to get proper SI units. So this 150 km/h needs to be in meters per second instead. So let's change that to meters per second. How many meters per second? Well, we divide by 3.6. So let's just grab my phone here and we'll pull up the calculator. Here's the calculator. Clear that. And I'm just going to do that, right? Divide by 3.6. So 150 divided by 3.6, because we know that I get 41.666. I'll say it's 41.7. 41.7 meters per second. Right? We got that by dividing by 3.6. Quick reminder that 3.6 is an exact number, so infinite sig digs in that number, which means we just keep whatever sig digs we have. Okay, so now we can put that in, right? It's 1/2 of 41.7 meters per second, and that's all squared, over G times H, 9.81 meters per second squared, times height, which is 94 meters here, 94 meters, times 100, of course. And then now we just start, start adding in, or start doing the thing. So here we have to square this before we do the 1/2. So square that first, because brackets times 7 times 41.7 is 1,738.8. I'm just going to say 1,739. So 1/2 of 1,739 meters squared per second squared. Over, and then 9.81 times 94, so 9.81 times 94 is 922.14 meters squared per second squared, right, times 100. And then we just need to cut that in half, so 1739 divided by 2 is 869.5 meters squared per second squared, because all we did was divide it by 2. It keeps the same unit there, and this one is 922.14 meters squared per second squared, obviously times 100. And then so we were just, last piece is dividing it by 922.14. That's equal to 94.3%. But then we have to look at our significant digits, right? If we look at our significant digits here, 94.3%. When we look at significant digits, we had 2 here for 94. We had 2 here. The 1 and the 5 in 150 are significant, but the 0 isn't because we can't trust it. So they could have been rounding it to the 10 kilometers an hour. So we only keep 2 significant digits, these 2 specifically, those 2 digits. So that's 94% efficient. And that's how you can solve this problem. The most important piece here is figuring out which energy equation is on top and on the bottom, and then being able to cancel out the mass. It's a very handy way to do things. Now I'm going to get to the bullet horsepower, the AK-47 horsepower question, but that's going to take a little bit of setup, so I'm going to pause the video and you'll see a little jump here. So just a sec. Okay, so here's the second one. We're trying to figure out the horsepower of an AK-47, and here's a terrible picture that I drew of an AK-47. Basically, it's change in energy over change in time, right? It's power. We're interested in power, so we need to know an energy and we need to know a time, how much energy is transferred and how much time it takes. So the basic, thing that a gun does is it shoots bullets very quickly, and each bullet will have a mass, right? There's a mass of the bullet and a speed of the bullet. So that's going to be kinetic energy. The whole point of a gun is to transfer kinetic energy. Take the chemical energy of the propellant inside and turn it into kinetic, right? So we might have that like chemical energy in there, and it's getting transformed into kinetic energy of the bullet. So we need to know a few things about that, right? We might want to know the mass of a bullet, the speed of a bullet on the way out. And thankfully Wikipedia has all of these stats for us. So I've got here the AK-47 stats. We have the mass of the bullet. There's 2 quantities here. There's 122 GR and 7.9 G. Which one is the one we want? Well, we got to think about what units we're using. We want to use kilograms, and the symbol for grams is just G. It's not GR, so G. This is the actual mass of the bullet. The GR is a different unit of mass. It's grains. It's an old unit where they used to have little grains of something that they would measure. So there's 122 grains, which is 7.9 grams. Let's put that in. The mass of this bullet, so the mass is 7.9 grams. But of course mass, we want things in kilograms, so that's 0.00 0.0079 kilograms. You divide by 1,000 to get kilograms, 0.0079 kilograms. The speed, we just directly get given the speed here. Muzzle velocity, 710 meters per second. Thankfully, Wikipedia gives it to us in meters per second. That's nice of them. 710 meters per second. All right, so now we can figure out EK. The kinetic energy of each bullet, mv squared over 2, which is 0.0079 kilograms times 710 meters per second squared over 2. And just like the last question, we have to do the thing inside the brackets first. Let's square this first before we multiply it by that. So that is going to be 0.0079 kilograms times, well, let's find out. Let's get a calculator out here. 710 squared, 710 times 710, 504,100. So 504,100. The unit here, meters squared per second squared. We're squaring the unit as well. Meters squared per second squared, all over 2, which is some number. So we're going to multiply it by 0.0079, and then that gives us an answer, and then we're going to divide it by 2. Gives us how many joules of energy. So 1991 joules of energy per bullet. Right, so that's the energy. That's the energy piece. We figured out the energy piece in our equation. Next up, the time. Right, we have to figure out how much time this takes. Well, again, Wikipedia has handily told us the rate of fire in rounds per minute. So 600 rounds per minute. 600 rounds per minute. But we want joules per second, right? Energy is joules per second, so we should probably figure out how many rounds per second. I think it's pretty obvious there's 60 seconds in 1 minute, so we have to cut this by a factor of 60. That's 10 rounds per second. 10 rounds a second. So we've got then 1,991 joules per bullet, and we have 10 bullets per second, right? 10 volts per second, 1,191 joules per bullet. So to figure out the time, right, we need energy over time. There's 2 options here. You can either say that 10 volts per second means 0.1 seconds per bullet. Right, 1/10 of a second per bullet. Therefore, power is 1,991 joules, like we measured, or like we figured out before, divided by 0.1 seconds, which gives you 19,910 watts. I remember watts is our unit of power, joules per second. A joule per second is a watt. Or you can multiply the joules per bullet times the bullets per second, and you'll get exactly the same idea. It's kind of like a speed, right? So you can do power over here. I'll do it a different way. Power is 1,991 joules per bullet times 10 bullets per second, right? And then you get a similar cross out, and you still get joules per second, and it'll still be the same number, right? Times 10 is the same as 19910 watts. 11990 watts. So we figured out how many watts. We figured out how many watts we've got, but we want horsepower. So we know that 1 horsepower is 745.7 watts. So, then all we have to do is take our 19,910 watts and convert it to horsepower. So times 1 horsepower per 745.7 watts. Right, per which means the watts are going to cancel out top and bottom, and we're going to be left with horsepower, and we just need to divide it. So let's do that. Let's do that in the calculator here. 19,910 divided by 745.7, we end up with 26.7 horsepower. 26.7 horsepower. Or sig digs, we got 2 sig digs here, 2 sig digs here. So we probably want just 2 sig digs, so 27 horsepower is our final answer. So an AK-47 has 27 horsepower, which means that if you shot, 4 AK-47s, you'd end up with something about as powerful as my car, which is weird to think about. So yeah, as it's shooting, that's how much energy, that's how much power it's putting out. This is why people have to really brace themselves to shoot. They have to brace against that 27 horsepower as they're shooting, or else they get knocked over. So yeah, that's your answer. An AK-47 has 27 horsepower. There's a fun fact for you. Yeah, that's it. Thanks for paying attention to the bonus content, and I'll see you with the next video. Bye.